Hello and welcome to C Programming 0 to Neural Networks. Today we are going to be introducing perceptrons. Perceptrons are the beginning of artificial intelligence. They're where the journey all sort of started way back in the 1950s when a guy called Frank Rosenblatt invented perceptrons, as the story goes. Let's check out Frank Rosenblatt. Frank Rosenblatt. See what he looked like. This is him working on some very old tech. Frank Rosenblatt in the 1950s with a computer which is covered in dials, and he's printing out some paper here, isn't he? So this guy invented the perceptron. Let's go back to the other screen. And this is the basic sort of makeup of a perceptron, which there's not that much to it actually, as we're going to find out here in this video, because I'm going to do a brief explanation of the perceptron, and then we're going to make one, and then we're going to see how it works. So let's go to Paint. How does a perceptron work? It's actually not very complicated, so don't worry about this one. We've already learned enough about the C programming language pretty much to make a perceptron. We're going to have to use an if statement, which I haven't covered yet because I haven't covered flow control, which I'm going to do next probably. And we're going to need the scanf as well, which takes terminal input, which I will do a separate video for, because the scanf function is actually quite a complicated function. It's a pattern matching function. We tend to just use it for taking user input, but it's quite a clever little function. It's underused, but the truth is we don't usually use C programming. We don't take terminal input anymore. Anyway, right, so let's make a perceptron. So we've got a perceptron that we feed some inputs into. So we're going to do a new job AI. So the purpose of the perceptron is to determine if someone should apply for a new job. So we'll call it job AI. Job AI. And we might feed in the input. We might say, so we want the inputs to be true or false, so 1 or 2. And it might be better salary. And then the next input might be travel time. And these can be either true or false, so 0 or 1. And this is also 0 or 1. Now, these inputs have varying importances, so a better salary is more important than travel time. Someone would travel a bit further for a much better salary, wouldn't they? So we multiply these inputs by a weight. So for this one, the weight might be 0.8. Now for travel time, it might only be 0.4 for the weight. Not very good equals there. And then the output of the perceptron, what we do is we set a threshold. And we could maybe make that equal to 1.5. And we'll say if the result of all the inputs is greater than the threshold, then the output of the perceptron is, yeah, we should apply for a new job. If the output is below the threshold, then the output of the perceptron is false and we shouldn't apply for a new job. So quite a simple example. I actually, this is part of my write-up. So I've started writing a LaTeX document to so that when we get to neural networks, I've got everything written down to go through. So I mean, these giant LaTeX documents, like 8,000 lines now. But not just for the series. Also, I wanted to sanity check my own everything I know about artificial intelligence so far. In particular, sanity check all the maths and re-go through all my mathematics that I've been using to make sure it's founded in rigorous mathematical principles, if you know what I mean, because I'm kind of a self-taught machine learning person. As I said before, I don't have 20 years experience working in AI. I've just sort of figured it out for myself. And so this is that bit of the document. And I did exactly this example, the job example. So better salary, travel time, more interesting, better prospects, and then dissatisfied with current job as the inputs. There's 5 inputs. And then I sort of randomly chose some weights that I thought were appropriate and set the same threshold, 1.5. But I never tested it to see if it would work. So what we're going to do today is we're going to test this in C programming and see if this model works, and sort of go through how we take a diagram like this and build a program out of it. So what we're going to have to do is we're dealing with the the values are like 0.8 and 0.4. So we've gone through data primitives, we've gone through primitive data types, and we've got ints and long ints and short ints, which all deal with whole numbers. We've got chars, which deal with characters, and we have floating point, double and long doubles to deal with decimal point numbers like these. And these are obviously small decimal point numbers, so we're definitely only going to need floats. So we're going to be using floats throughout our application. We're going to need a float for each input, a float for each weight. We're going to have an overall float for the perceptron, and we're going to have a float for the threshold as well. So let's do this. Let's model this and see if it gives us a good, based on these weights and these inputs, let's see if it gives us a good idea of, let's see if it makes a good, should I apply for a new job AI, that kind of the example that I made. So let's do that. Percept.c. We're only going to need one library. We're going to need the standard input output library as always, and we're going to need only one function as well. So this is going to be quite a simple program. It's not going to take particularly long to make. We're going to need a float p to represent the perceptron, and we're going to need a float threshold to represent the threshold, and we're going to set that to 1.5. The thing about artificial intelligence and neural networks, there's a lot of magic numbers in artificial intelligence and neural networks. This value of 1.5, I mean, it's not plucked out of thin air. I sort of looked at the data and thought that's an appropriate value. But it is a bit of a guess at the same time, and a lot of neural network programming is kind of guessing good values as initialization parameters. Anyway, that's another story for another time. So we're going to need a float x. We're going to have various inputs, so we'll do x1. And then that input is going to need a weight attached to it. It's also going to need w1. And to model this, we're going to need 5 lots of them, aren't we? So we're going to need x2, w2. Let's do these all at the same time. We're going to need x3, w3, x4, w4, x5, w5. And that is all the data we need. So that is a model, a programming model of this diagram of a perceptron. And we're going to need to introduce an if. So we've not covered ifs yet, but they work very similar to, well, not similar to loops, but the same kind of thinking behind them. So if we do if, we have a condition which goes between the open and closed parentheses, and if that evaluates to true, the code between the open and closed curly braces will run. If this evaluates to false, it won't run. But unlike a loop, it doesn't loop round again. It happens one time. And we can also put an else condition, and if this first part doesn't run, this part will run. But if this part does run, this part won't run. So it's a one or the other, like a switch. And we want to put if p is greater than threshold, and in our example we want to output some kind of message. We're going to put yes, you should apply for the new job, and then else we're going to put no, you should not apply for the new job in our job AI example. So we should probably label these. So better salary, travel time, that's the next one, more interesting, more, I'll get rid of that, more interesting, better prospects, and the final one is dissatisfied. And we are going to need to set these weights, aren't we? So I did 0.8 for that one. I did 0.4 for that one. 0.6 for more interesting, seems about right. 0.7 and 0.8. So to recap, each of these inputs is going to be multiplied by these weights, which represent the importance of the input. So better salary, I mean the range is between 0 and 1 for these weights. A better salary is quite a high importance, so it gets quite a high weighting. Travel time's not as important, so it gets a lower weighting. More interesting, reasonably important. Better prospects, slightly more important still. And then if someone's dissatisfied or unhappy in their current job, then that's going to be quite a significant input as to whether they should apply for a new job. So that gets 0.8. And again, magic numbers. These are sort of just picked because, well, we'll find out if they work, won't we? And next, we need to get our inputs. Now, we could just specify these and try out the program, but what we really want to do is have the program prompt for input. So we can ask every time we run up the program, we can ask whoever's using it to enter those values. And for that, we're going to need to use scanf. So we're going to need another float, which we're going to call input. And for each of these, we're going to do a scanf. So scanf, which is like the sister function to printf. So whereas the printf outputs something from the standard out, the scanf function inputs from the standard in. So it works quite similar to the printf function in that we have to specify the type of input we're going to be getting, just as when we output with the printf, if we're going to output some values, we have to specify the type again. And %f represents a float value, which kind of makes sense, doesn't it? We have to put the address of operator in the scanf, which we haven't covered, and we'll certainly do an entire part on and talk about at great length eventually when we get to that level. So we put the address of this input float into the scanf function. So this is going to prompt the user, and we also want to put a message to describe what we're asking. So we're going to use the printf for that, and we're going to put does the job have a better salary ? And we want to let the user know the range of inputs. So 0 false, 1 true, and then maybe put a colon at the end. And I reckon we want to put that on a new line as well. So we prompt that, then we get the user input, and then we want our x1 to equal that input. Now we can reuse this input value over and over again, so we can do the same thing again for travel time. We need to change the message though. We want to put is the travel time better? Easiest way to say it, and then we just make x2 equal to the input, and then we can copy that again. And this is more interesting. Is the job more interesting? And then once again, we can make that equal to the input. Better prospects. We're going to ask, does the job have better prospects? And we make x4 equal to the input. And the last one, dissatisfied, where we can write, are you unhappy in your current job? ? And we make x5 equal to the input. So that all that's left is to calculate the overall value of the perceptron. So we've already declared the perceptron up here, so we can just do P equals. Now we do the input times the weight, so x1 times w1. And we want to add all these together. So let's put these in brackets just to separate them. And we want x2 times w2, x3 times w3, x4 times w4, and finally x5 times w5. And this is the algorithm which powers this artificial intelligence. This is AI, this new job AI that we have made. And all being well, this will I think I'm going to put a title up at the top. So I'm going to do printf. I'll stick that on a new line. I'll put new job AI. I'm going to do another new line and then do like an underline for that. That should do us. Right, let's see what results we get. So, new job AI. Does the job have a better salary? Yes. Is the travel time better? No. Is the job more interesting? Yes. Does the job have better prospects? No. Are you unhappy in your current job? No. You should not apply for the new job. Right, to check it's working, let's do it as if everything's better. Does the job have better salary? Yes. Is the travel time better? Yes. Is the job more interesting? Yes. Does the job have better prospects? Yes. Are you unhappy in your current job? Yes. You should apply for the new job. So it appears to be working. So let's think of a real example. So we have a typical software engineer kind of job prospects situation where they're in a nice stable job, but there's a really fancy startup over in the a bit further away, but working on some really interesting stuff. So, and it doesn't pay better. So no, it doesn't pay better, and the travel time is the travel time better? No, it's further away. But is the job more interesting? Yes. Does the job have better prospects? That's a difficult one to quantify. If a startup makes it, then I guess so. Shall we say this is an optimistic person and they're going to say yes? And are they unhappy in their current job? We're going to say yes for this example. Yes, you should apply for the new job. Let's do another example. Does the job have a better salary? No. Is the travel time better? No. Is the job more interesting? Yes. And there's better prospects, and you're unhappy in your current job? Yes, you should apply for the new job. We have successfully made in this series our first artificial intelligence. Now, I will admit it's not the most intelligent of artificial intelligences, but it is where artificial intelligence begins. So let's go back to the diagram. So we build more complicated things than this now for artificial intelligence. But we have a modern AI called a multi-layer perceptron, which is basically these all sort of connected together in a network, which isn't that far away from just a neural network, is it? With neural networks, we include biases, an overall bias on what we would call a neuron and not a perceptron. But the basic premise of taking a model of inputs and aggregating towards some kind of output based on weights is basically how artificial intelligence works. I mean, things have got a lot more complicated. We basically added a load of complicated mathematics to the problem, and we've added non-linear activation functions and those kinds of things. But this is actually an artificial intelligence. It's a very simple one, but it is an artificial intelligence, and look how simple the program is. The entire algorithm is this one line of code that makes it all work. The rest of it is just taking inputs, and we can model other kinds of questions. It's simply a matter of defining what weights that we want and what the threshold is going to be. There's a very limited AI that we can't do much of. In a neural network, these weights are sort of adjusted by another algorithm to get it to a sort of we can input some data, and then the neural network sort of trains on that data and adjusts all its parameters to arrive at a good model for that data. And so this is a good example, a good introduction to artificial intelligence. Let's run it one more time. Does the job have a better salary? Yes. Is the travel time better? Yes. So it's got a better salary and the travel time is better, but it's not a more interesting job. It's a more boring job, and it doesn't have better prospects. Now, a good thing about this AI is we don't have to put ones and zeros because we're dealing with floats. So are you unhappy in your current job? Well, someone could be like 50-50. They're not sure. They're not massively happy in the current job, but they're not massively unhappy either. So we can actually put a 0.5 in for that input and see what we get. Oh, yeah, they should apply for the new job. So better salary, better travel time, and they're 50% on the new job, but it's not more interesting. It doesn't have better prospects. So according to this Perceptron AI, that person should switch jobs and apply for the new job. And we've made our first AI. So next in the C programming, we're going to do a bit more C programming. We're going to introduce some new things. So we're going to go through this if statement here and if else's, and that falls under the umbrella of flow control. So we're going to be covering flow control extensively, and we're going to introduce this scanf. Now, as I said, we don't really do much of this in C programming. So this AI, we wouldn't really want to make this program that you run it in a terminal and people type things in on a terminal. What we could do is build a web front end for it, couldn't we? And we could make a form that goes back to a server and inputs that form data into those inputs after asking somebody on a web form, and then sends the answer back to their web browser and renders it on the screen. So we tend to do more things like that, don't we, in modern computing, because we have graphical user interfaces. There was a time when computers, what you're looking at here, this typing stuff in a terminal, was computers, but obviously we've come some way since then. So as a result, scanf is not a very heavily used, apart from in learning C programming. It's about the only time that we ever really use scanf, and for a bit of pattern matching if we need to do pattern matching. But it's a limited function because it's blocking. By nature. Anyway, so C programming. I was going to finish saying this. It's not going to take us too long to go through all of the C programming language. One of the very best things about the C programming language is it's a compact language. It's quite a small language. There's not a massive amount to it. Learning the whole C programming language isn't that difficult and doesn't take that long. Understanding the C programming environment and how data exists in memory, that's more complicated. But the actual language itself is actually quite compact and quite simple. Compare that to, say, C++, for example, which is a giant language. C++ is massive. You could spend 10 years learning C++ and still find new things to learn about C++. You're not going to find that in C programming. You're going to find that you could learn the whole thing in a month if you really put your mind to it. It takes a lot longer to learn how to get good at implementing programs in the C programming language, and to learn good practices and all those kinds of things. And hopefully in this series, this is going to be a good series to get somebody started with the C programming language all the way up to being very good at it in a very quick time. Obviously always heading in the direction of neural networks. So we have pretty much finished there now. We can call that a day. We have built our first artificial intelligence. One more time before I finish the video. Does the job have a better salary? No, it doesn't. Is the travel time better? No, but it is a much more interesting job, which does have much better prospects. And yeah, once again, 50% happy, 50% unhappy in your current job. Yeah, you should apply for a new job in that situation, according to this Perceptron model, which again, when I wrote this, I didn't test it out, I just sort of wrote the values. So this does confirm that this bit of this document that I've made, I can happy with that. I don't have to go back and amend all these values and change them if somebody wants to do what I've just done there. But we're going to be doing lots of this in this series as we approach neural networks. So we're going to have to sort of understand what a neural network is as a diagram, and then understand how we then go about programming that thing. And first is what we've just gone through here is a good way to go about it. So we start with sort of laying out the data and figuring out what data we've got, and then we deal with the inputs and the outputs, what we're going to do with the inputs and what we're going to do with the outputs. And in this case we've scanned F the inputs, and then we've just ifed on a threshold and print F the outputs, which is a true or a false, which is a yes or a no, you shouldn't apply for a new job. So that is hopefully going to serve as a nice easy introduction to building artificial intelligence in the C programming language. And perceptrons are interesting. Let's jump back to Frank Rosenblatt. So there's actually a book on this, which Perceptrons book images. There's a book about perceptrons. It's not written by Frank Rosenblatt. I think this was written in like 1980 or something, and Frank was doing his work in the 1950s. It's written by Marvin L. Minsky and Seymour A. Papert. And this, I wouldn't mind getting it actually. I think I'll pick this book up sometime. I'm a bit of a reader, me. I've read a lot of computer books in my time. I do like a good programming book, but obviously this is a bit dated now, and but just out of interest I might read it. So that is perceptrons, and that's where artificial intelligence begins. It all starts with perceptrons, and then perceptrons led to multi-layer perceptrons, which led to feed-forward neural networks, which lead on to all the stuff we do today, convolutional neural networks, recurrent neural networks. There's all kinds of different ones now. But they all have the basic same premise, where we have inputs, weights, and they sort of arrive at some kind of sum in the end. And obviously programming a multi-layer perceptron involves a lot more programming than we've just done there. But we'll get to that in time. Right, okay, I will see you next time.